Close your eyes for a moment and imagine a time before there were oceans, before there was land, before even the air we breathe. A time when our world did not yet exist. About 4.6 billion years ago, the sun itself was still young. Around it drifted a vast cloud of dust and gas, tiny particles born from earlier stars that had lived and died long before. Slowly, very slowly, gravity began to pull these particles together. They swirled like smoke, collided, and fused. What began as grains no bigger than sand would, over countless millions of years, grow into something far greater. One by one, these pieces clumped into larger and larger bodies. Some grew to the size of mountains, then continents, then small worlds. Among them was the young Earth. At first it was not a gentle place. The early planet was molten, a globe of fire. Without a crust to cool its surface, temperatures soared above 200 degrees Celsius. Volcanoes poured rivers of lava into a landscape that was always changing, always unstable. And as if that were not enough, the sky itself was dangerous. Asteroids and comets rained down in endless numbers, their impacts shaking the planet and adding to its heat. Radiation from the young sun was stronger than it is today, and without a protective atmosphere, Earth's surface was bathed in harsh energy. It is difficult for us to imagine this time. We see our world as a place of forests and rivers, but in its beginning it was more like a glowing forge, a place of fire and molten rock. Geologists call this chapter the Hadean Aeon, a name that recalls the ancient Greek word for the underworld. It was, in every sense, a hellish beginning. And yet, in that chaos lay the seeds of what would one day become home, because even as the world was shaped by fire and violence, its future was being written. Matter was gathering, cooling, preparing. It is strange to think. We are here now because the planet once burned. Life, as fragile as it seems, begins with fire. Pause with that thought. From a fiery globe, something new was about to arrive. Something gentle, something soft, something essential. The gift of water. From the glowing furnace of Earth's beginning, another force soon entered the story. One that would soften the planet's fiery face and change it forever. Water. We take it for granted now. The seas that stretch beyond the horizon, the rivers that carve valleys, the rain that falls gently against our windows. But in those earliest ages, Earth was dry. Its surface was molten stone, its air filled with poisonous gases. To make a world of oceans, something else was needed. Something that would arrive from the skies above. Scientists believed that comets, rich in ice, were among the first visitors to bring water to Earth. Each collision may have seemed like violence, but hidden inside was the promise of rivers and seas. Piece by piece, drop by drop, these cosmic messengers delivered the element that would someday cradle life. But comets were not the only source. Deep within the young Earth, volcanoes erupted endlessly. With them came gases, steam, carbon dioxide, and many others. The atmosphere thickened, and as the planet began to cool, the steam condensed into rain. Imagine it, rain that did not fall for hours or days, but for millions of years without end. A planet wrapped in storm. The sky a grey shroud, the ground a sea of black rock slowly drowning. Over time, the rain filled the low places, carved basins, and pooled into the first oceans. They spread across the globe until Earth, once red and glowing, turned blue. From space it must have seemed transformed, from a fiery ember into a world of water. And yet this was not the calm blue we know. These early oceans were restless, stirred by tides stronger than today's, whipped by winds, and warmed by the heat of the planet below. They were, in many ways, wild and chaotic seas, but they were seas nonetheless, and that changed everything. For where there is water, there is the possibility of life. Oceans are not just places to swim or sail. They are laboratories of creation, mixing chemicals and energy in ways that can produce something new. If fire was the beginning, then water was the invitation. an invitation for something more delicate to appear, something that would one day look back at the stars and wonder how it all began. But for now, Earth was still young, a planet of storm and sea, waiting in silence. With oceans stretching across the planet, Earth had taken its first great step toward becoming a home for life. But for a long time, it was still an empty world. The seas rolled endlessly, waves broke against barren rock, and volcanoes continued to breathe fire into the air. There were no forests to soften the landscape, no birds to fill the silence, no fish to stir the waters, only the sound of storms and the hiss of rain. And yet in this quiet ocean, something extraordinary was about to happen. Somewhere in the deep, where minerals and heat met the restless chemistry of the sea, the first spark of life emerged. We may never know the exact place or the exact moment. Perhaps it was around a hydrothermal vent on the ocean floor where hot water bubbled from beneath the crust. Or perhaps it was in a shallow pool, warmed by sunlight and fed by minerals from volcanic rock. What we do know is that molecules combined in a way they never had before. Patterns formed, structures copied themselves, and tiny chains of chemistry began to grow. In the simplest of forms, life was born. The first creatures were not plants or animals as we know them. They were single-celled organisms, fragile, microscopic, and yet filled with potential. They floated in the seas, living only a few moments at a time, yet able to divide and reproduce. Slowly, patiently they multiplied. Imagine holding a drop of that ancient ocean in your hand. To our eyes it might look empty, but in truth it carried the earliest ancestors of all living things. From these tiny beginnings would one day come forests, whales, insects and humans. Every heartbeat on Earth traces back to that first quiet spark. It is almost impossible to grasp the scale of time between then and now. Billions of years stretch between those first cells and the world we know. But the miracle itself is simple. From lifeless matter, life arose. And so, the silence of the oceans was broken. Earth was no longer just stone and water. It had become something more, a living world. Yet life was still fragile, vulnerable to the harshness of its planet. For now, it remained small and hidden. But in time, it would transform not only the seas, but the very air itself. For hundreds of millions of years, those first single-celled organisms lived quietly in the oceans. They drifted, divided, and endured. To us, they might seem insignificant, yet slowly they began to change the planet in ways that would echo through all of history. Among them were remarkable microbes, cyanobacteria, sometimes called blue-green algae. They had discovered a way to capture the energy of sunlight. With sunlight, water, and simple chemicals, they could build what they needed to live. And in this process, they released something into the air, oxygen. At first, the oxygen they produced vanished quickly. It combined with iron in the oceans, rusting it into layers that geologists still find today. But over time, the oxygen began to accumulate, seeping into the atmosphere, changing it forever. It was a quiet revolution, carried out by cells too small to see. But the result was immense. Earth's skies were transformed. What had once been an atmosphere thick with methane and carbon dioxide slowly gained oxygen. The planet turned from a yellowish haze into something closer to the blue skies we know today. And yet, this gift of oxygen was not welcomed by all. For many of the early life forms, oxygen was poison. The very gas that allows us to breathe was, for them, deadly. Whole communities of microbes vanished. Others retreated into deep places where oxygen could not reach. But for those that adapted, oxygen was opportunity. It allowed new forms of energy, stronger and more efficient than before. The stage was set for greater complexity. Still, this new world came with a cost. As oxygen rose, it stripped greenhouse gases from the air, cooling the planet. The Earth began to freeze, its oceans locked beneath ice. For millions of years, the world may have looked like a white marble drifting in space, a snowball Earth. And yet, even beneath the ice, life persisted. Tiny cells clung to the deep oceans, waiting, surviving, preparing for the next chapter. The Great Oxidation Event was not just a change in chemistry, it was a turning point. A planet of stone and water became a planet of air and sky, and in that air for the first time there was breath. From here life would not remain simple. It would grow more complex, more diverse and more astonishing. But before it could rise, it first had to endure the silence of ice. The Earth, once fiery and then softened by oceans, now faced a new and nearly total silence. Around 2.4 billion years ago, the planet slipped into a deep freeze. With so much carbon dioxide removed from the air by oxygen-producing microbes, the atmosphere could no longer hold in the sun's warmth. Slowly, then suddenly, ice spread from the poles toward the equator. It is thought that even the tropical seas froze over, sealing life beneath a thick crust of ice. From space, Earth may have looked like a pale, frozen sphere. A snowball Earth. For millions of years, glaciers covered continents, and the oceans lay still beneath their icy roofs. The world was locked in cold, and for many it must have seemed that life's fragile experiment had ended. And yet, deep below the ice, warmth lingered. Around volcanic vents at the bottom of the oceans, heat and minerals still poured into the water. In these hidden places, tiny organisms endured. Protected from the cold, they clung to survival, multiplying quietly in the dark. Meanwhile, the planet itself was restless. Volcanoes continued to erupt, releasing carbon dioxide back into the air. Slowly, over countless centuries, the greenhouse effect returned. The atmosphere thickened again, trapping more heat, and the long winter began to thaw. Imagine the moment. After millions of years of silence, the ice began to crack. Great sheets broke apart, crashing into the oceans. Rivers of meltwater carved through the frozen crust. Sunlight touched the seas once more, and the blue of the earth returned. The thaw was dramatic, a transformation from a world of silence to one of flowing water. Oceans moved again, winds shifted and climates softened. For life, it was another chance. The microbes that had survived in hidden refuges spread once more, reclaiming the seas. Snowball Earth reminds us of the planet's extremes. It shows how fragile the balance of climate can be, how quickly a world can tip from warmth to ice. And yet, it also reveals resilience. Even in the harshest of conditions, life endures. With the ice retreating, the stage was set for something new. Life would not remain as it had been. Slowly, cells began to change, learning cooperation, preparing for the leap toward greater complexity. As the ice retreated and the ocean stirred once more, life was given a second chance. For billions of years, cells had remained simple, tiny bubbles of chemistry living alone. But survival often favours cooperation, and somewhere, in those ancient seas, two very different kinds of cells came together in a partnership that would change the future of Earth. One cell swallowed another. Normally, that would mean the end of the smaller one, but instead of being digested, the smaller cell continued to live inside its host. Over time, the two formed a bond. The smaller cell provided energy, the larger cell offered protection. Together they became something new. This was the beginning of the eukaryotic cell, the kind of cell that makes up plants, animals, fungi, and eventually us. Inside every one of our cells today, tiny structures called mitochondria still carry the memory of that ancient alliance. They were once free-living microbes. Now they are part of us. The rise of eukaryotes was quiet but profound. These cells were larger, more complex and more versatile than anything before them. They could build structures, store information, and interact in new ways. The possibilities expanded enormously. And yet, for hundreds of millions of years, life still moved slowly. The oceans were filled mostly with these single cells, drifting, dividing, waiting. Evolution, like the planet itself, often takes its time, but patience carries rewards. Over time, some eukaryotic cells began to group together. They discovered the power of unity, not just living side by side, but working as one. This was the first step toward multicellular life. From cooperation came complexity, and from complexity came the foundation of every living creature we know. It is humbling to think that we, with all our thoughts and histories, began with such a quiet partnership, one cell within another. Without that bond, Earth might still be a world of microbes, its oceans alive but simple, its lands barren and silent. But because of it, the story was ready to move forward. Soon, the seas would host creatures unlike anything before, soft-bodied forms that drifted, grazed, and stretched toward new ways of being alive. With eukaryotic cells now established, the stage was set for something extraordinary. For billions of years, life had been small and invisible to the naked eye. But around 600 million years ago, the oceans began to host a new kind of living world, larger, stranger, and filled with forms unlike anything we see today. This period is known as the Ediacaran, named after the hills in Australia where fossils of these creatures were first found. The organisms of this age were soft-bodied, delicate, and mysterious. Some looked like fronds of seaweed, anchored to the ocean floor. Others resembled discs pressed into the sand, or quilted mats spread gently across the seabed. They had no shells, no bones, no teeth. There were no predators to threaten them, no need for armour or speed. In their stillness, they absorbed nutrients, perhaps filtering water, perhaps sharing energy through sunlight and chemistry. It was, in many ways, a peaceful world. Imagine the scene. On the floor of a shallow sea, carpets of soft creatures ripple gently as currents pass over them. Pillar-like forms sway like forests beneath the water. Round, flat organisms rest in quiet clusters. It is alien and unfamiliar, and yet it was the first great community of visible life on Earth. For nearly 60 million years, the Ediacaran organisms thrived. They spread across the oceans, filling the seafloor with living shapes. But their world was fragile. They were adapted to an environment with little disturbance, where resources were plentiful and danger was absent. And perhaps that is why their time eventually ended. Evolution favours change, and in the background, new creatures were preparing to arrive. Creatures that could move, that could bite, that would not live in harmony, but in competition. The Ediacaran forms remain a mystery to us. Scientists still debate exactly what they were, ancestors of animals, or an experiment in life that left no descendants. What is certain is that they mark a moment of transition. For the first time, life had become large enough to see, complex enough to wonder at, and abundant enough to shape entire ecosystems. The quiet age of soft forms would soon give way to something far more dramatic, the sudden, explosive arrival of animals. After the long calm of the Ediacaran age, the oceans were about to change in ways both sudden and profound. Around 540 million years ago, life took a leap forward, a burst of diversity so rapid and so sweeping that scientists call it the Cambrian explosion. For billions of years, life had been simple. For tens of millions, it had been soft-bodied and still. But in the Cambrian, creatures appeared with shells, teeth, claws, eyes, and new ways of moving. Predation was born, competition began. The oceans became not only places of quiet survival, but of struggle, invention, and constant change. Fossils tell us of remarkable beings. Trilobites, armoured like beetles of the sea, crawled across the seafloor. Anomalocaris, a predator with grasping arms and circular jaws, hunted with speed and power. Opabinia, a creature with 5 eyes and a long flexible proboscis, probed the sediment for food. Worms, sponges, and early mollusks added to the variety. And then, for the first time, vertebrates appeared. Tiny, soft-bodied fish-like creatures swam through the currents, ancestors of all animals with backbones. In their fragile bodies, the blueprint of future sharks, birds, and humans was already present. Why did life flourish so suddenly? Scientists still search for the answer. Perhaps rising oxygen levels allowed larger and more active bodies. Perhaps new genetic tools like the development of body plans opened doors to endless possibilities. Perhaps the arms race between predator and prey drove innovation at an astonishing pace. Whatever the cause, the result was clear. The oceans filled with strange and wondrous forms. Where once life had been slow and quiet, now it was varied, active and complex. It is hard to overstate the importance of this moment. The Cambrian explosion laid the foundations for nearly every major group of animals alive today. The basic body plans we recognize, creatures with shells, legs, eyes, spines, all emerged in this window of time. And yet, while the seas swarmed with invention, the land remained barren. Bare rock stretched across the continents, lifeless and still. But not for long. At the edges of those seas, life was preparing another leap, one that would forever change the face of Earth. While the oceans brimmed with new life during the Cambrian, the continents remained quiet and bare. No forests softened the landscape, no insects buzzed in the air, only rock, sand, and the wind's long silence. Yet at the edges where sea met shore, something remarkable was beginning. A few humble pioneers crept onto the land, not animals, but simple green organisms. Algae and fungi formed partnerships, combining their strengths. Together they became lichens, able to cling to bare stone and slowly break it down. With time, their work created the first soils, a thin, fragile layer that would one day nurture forests. Once soil existed, another step followed. Mosses appeared. These small plants had no deep roots, no tall stems. Each leaf was only a single cell thick, and yet they were tenacious. They spread quickly, covering rock and soil like a soft green carpet. For nearly 40 million years, mosses ruled the land. Imagine that landscape. Empty continents broken only by low mats of moss. No trees, no grasses, only the sound of wind across stone. And yet, it was the beginning of something vast. The land was no longer lifeless. This slow greening of the continents changed more than just the scenery. Plants began to draw carbon dioxide from the air, releasing oxygen in return. They softened the climate, laid the foundation for food webs, and prepared Earth for larger, more complex organisms. Life on land had taken its first small steps. Fragile, low, and simple, but persistent. Each root, each leaf, was a foothold against rock and time. From here, the land would never again be empty. Soon, plants would grow taller, forests would spread, and animals would follow. The continents were waking slowly but surely to the sound of life. With the Cambrian seas alive with strange and wondrous creatures, the story of life pressed forward into a new chapter. Around 485 million years ago, the Ordovician period began, and with it came an expansion of life so rich that the oceans looked entirely different from what they had before. Coral reefs began to form for the first time, creating underwater cities of stone and living tissue. These reefs offered shelter, breeding grounds, and countless new opportunities for life to thrive. Mollusks flourished. Squid-like creatures with long, straight shells called nautiloids grew to enormous sizes, some stretching several meters in length. They became the new masters of the sea, gliding through the water with quiet strength. Trilobites, though still numerous, faced stronger competition. Their once dominant rule of the seafloor now shared space with brachiopods, bryozoans and early echinoderms. Starfish-like creatures spread across the seabed. Crinoids, with stalks like lilies anchored to the ground, waved their feathery arms into the currents, filtering food from the water. It was also during this time that the first true fish with hard external armour appeared. Small and primitive, they marked the earliest ancestors of all vertebrate lineages to come. In their plated bodies, we see the beginnings of jawed fish, amphibians, reptiles, and even mammals far in the future. Meanwhile, the land itself was stirring. Plants had already begun their conquest of the continents with mosses and lichens. But now they evolved new strategies. Some grew taller, reinforced by a new material called lignin. For the first time, plants could rise above the ground, stretching toward the sun in search of light. Small forests began to form along coasts and riverbanks, spreading oxygen into the air and drawing carbon dioxide from the sky. The Ordovician world was vibrant, full of expansion and diversity. It seemed as though life had found balance, seas rich with creatures, lands greening with plants, and ecosystems more intricate than ever before. But in Earth's story, balance is rarely permanent. Just as life reached this flourishing height, change was coming. Quiet at first, then sudden and severe, the planet would soon enter its first great crisis, a mass extinction that would sweep away most of this abundance. The Ordovician seas, once so full of life, soon faced a silence deeper than any before. Around 445 million years ago, the Earth slipped into a great crisis, its first mass extinction. The cause was rooted in change. Plants had been drawing carbon dioxide from the air in ever greater amounts, and volcanoes no longer released it quickly enough to replace what was lost. The atmosphere thinned of greenhouse gases, and with less heat trapped, the planet began to cool. Glaciers spread across the supercontinent of Gondwana, which then rested near the South Pole. Great sheets of ice advanced, locking away the ocean's water. As ice grew, sea levels dropped. Shallow seas, where most life had flourished, drained away, leaving behind barren mudflats. The cooling ocean could no longer hold the warmth or the chemistry that so many species depended upon. Coral reefs perished. Trilobites, once plentiful, suffered terrible losses. The mighty nautiloids, apex hunters of their age, dwindled. Brachiopods, bryozoans, and countless smaller creatures vanished in silence. By the time the extinction had ended, nearly 85% of marine species were gone. Whole ecosystems collapsed, as if the oceans themselves had exhaled and gone still. And yet, life did not end. Some creatures found refuge in deeper waters, where conditions were more stable. Others adapted slowly to the colder climate. In these survivors, the story continued. It is difficult to imagine such a world. Oceans that had been vibrant gardens became graveyards of silence. The planet had taken life to its first great height, only to remind it of fragility. Still, the Ordovician mass extinction carried with it an important lesson. Each crisis clears the way for renewal. When the ice began to retreat and the seas returned, the survivors would inherit an emptier world, a stage upon which new forms of life could rise. This was not the last time Earth would test its creatures. Far from it. But it was the first great reminder that change is constant, and survival is never guaranteed. In the silence that followed the Ordovician extinction, the Earth seemed to pause. Oceans, emptied of so many creatures, rolled quietly beneath cold skies. But even after such loss, life has a way of returning. Slowly, patiently, it began again. This was the Silurian period, beginning about 443 million years ago. The ice that had locked the planet in cold began to retreat. Glaciers melted, seas rose, and shallow waters once more covered the edges of continents. With warmth and water came renewal. Coral reefs returned, fragile at first, then growing larger and stronger. They became the foundations of new ecosystems, home to a variety of fish, mollusks, and invertebrates. Crinoids stretched their feather-like arms into the currents. Trilobites, though fewer in number, crept once more along the sea floor. And in these seas, another quiet transformation was underway. Fish had existed before, but now they grew stronger, more diverse, and more capable. Some had heavy armour, plates that shielded their bodies from predators. Others developed new forms of fins, granting them greater agility in the water. In these early fish, we see the first hints of jaws, the innovation that would open new possibilities for feeding, hunting, and survival. While the oceans regained their richness, the land began to change as well. Plants that once clung close to the ground now found ways to grow taller. They developed vascular tissues to carry water and nutrients upward, allowing them to rise toward the sunlight. The first small forests appeared along riverbanks and coastlines. With them came another step, the earliest land-dwelling animals. Primitive relatives of scorpions and millipedes ventured onto the continents, their bodies adapting to breathe air instead of water. They were small, cautious pioneers, but their presence signalled a future where animals would no longer be confined to the sea. The Silurian was not an age of drama, but of quiet healing. It was a time when the earth gathered itself after loss, when the foundations were rebuilt, and when new possibilities emerged from old struggles. From this recovery, life was ready for another leap. In the seas, fish would soon reach their golden age. On land, plants would spread into towering forests, and in both realms, the world would grow more complex than ever before. As the Silurian gave way to the Devonian, around 419 million years ago, the Earth entered a new and vibrant chapter. This was an age when fish, in all their variety, filled the oceans and rivers so abundantly that scientists call it the Age of Fishes. The seas swarmed with armoured placoderms, fish with bony plates that gleamed like shields. Among them was the mighty Dunkleosteus, a predator more than 10 metres long, its jaws strong enough to crush even the hardest shells. Smaller fish, too, multiplied in endless forms, some sleek and swift, others strange and experimental. The invention of jaws had unlocked possibilities, and the oceans responded with a flood of diversity. Sharks began their long lineage in this age as well. Though smaller than the giants that came later, their bodies carried the same traits we recognise today: cartilaginous skeletons, sharp teeth, and a relentless drive to survive. Rays and lobe-finned fish also swam these waters, their fins beginning to strengthen into structures that could one day support weight. While oceans flourished, the land was undergoing a transformation no less dramatic. Plants grew taller, developing trunks and branching leaves. Forests of early trees spread across the continents, their roots digging deep into the soil, stabilizing the ground and reshaping rivers. These forests pumped oxygen into the air, making the atmosphere richer, fresher, and more favourable for animal life. And it was here, in this changing world, that one of life's most daring steps took place. Certain lobe-finned fish, with fins strong enough to push against the ground, began to explore the edges of water and land. They had both gills and primitive lungs, allowing them to breathe in two worlds. On quiet, swampy shores, they hauled themselves onto muddy banks, clumsy but determined. These were the ancestors of amphibians, the first vertebrates to walk upon land. Their movements may have been awkward, their journeys short, but the step was monumental. From them would descend reptiles, birds, mammals, and eventually us. The Devonian was an age of flourishing, of invention, of bold experiments in both sea and land. But even here, abundance was fragile. Beneath the richness of this time, unseen forces were building toward a catastrophe, one of Earth's great extinctions waiting in the deep shadows of time. The Devonian seas had seemed endless in their vitality. Fish of every size and shape swam through reefs, rivers, and open waters. Forests covered the continents, their roots deepening, their branches reaching high toward the sun. Life had stretched into new forms and new places. It must have felt in that long chapter of Earth's story as though the expansion could continue forever. But change is constant, and with it comes loss. Around 360 million years ago, the Age of Fishes came to a sudden halt. What followed was one of Earth's great turning points, the late Devonian extinction. The causes remain uncertain, a puzzle still studied today. Some point to widespread volcanic activity, which could have poured ash and gases into the atmosphere, darkening skies and altering climates. Others suggest that the rapid spread of forests may have played a role. Trees, in their hunger for growth, pulled enormous amounts of carbon dioxide from the air. This cooled the planet and destabilized the delicate balance of the oceans. Whatever the exact trigger, the results were devastating. Oxygen levels in the seas dropped sharply. Entire regions of the oceans turned into dead zones, where life could no longer survive. Coral reefs, which had blossomed into complex cities of life, collapsed and did not return for millions of years. Armoured fish, once the rulers of the sea, dwindled and disappeared. The giant Dunkleosteus, with its crushing jaws, vanished into history. Trilobites too suffered terribly, their numbers shrinking further. In total, nearly 3/4 of all marine species were lost, and yet on land, life continued to find strength. Forests persisted, stretching across continents. Amphibian ancestors, though fragile, held on. Some of them adapted further, strengthening their limbs and lungs. In time, they would give rise to creatures even more capable of living away from water. The Devonian extinction reminds us of the tension between abundance and fragility. Life can flourish brilliantly, yet it is always bound to the conditions of its planet. A shift in climate, a change in chemistry, a flicker of chance, and whole worlds of creatures can vanish. But extinction is never the end of the story. The silence that followed the Devonian collapse was not emptiness, but preparation. From the ruins of lost oceans, new forms would rise. Larger forests, greater oxygen, and creatures stranger and more formidable than any that had come before. In the wake of the Devonian extinction, Earth entered a new chapter. Around 359 million years ago, the Carboniferous period began, and with it came a transformation unlike anything before. The seas were quieter, yet on land, life flourished in new and extraordinary ways. Forests spread widely, carpeting the continents in green. Towering plants, club mosses, horsetails, and ferns grew as tall as buildings. Their trunks rose high, their branches unfurled into canopies that shaded the ground. Beneath them, vast swamps stretched across the land, filled with tangled roots and shallow pools. The air grew thick with moisture, heavy and warm. These rainforests were unlike any that exist today. The atmosphere held far more oxygen, almost twice the level we breathe now. With so much oxygen, life responded in unusual ways. Insects and arthropods grew to enormous sizes. Dragonflies with wingspans nearly a metre across soared through the humid skies. Millipedes the length of cars crawled along the forest floor. Giant scorpions lurked in the undergrowth. To walk through these forests would have been to enter a world both familiar and alien, where ordinary creatures had become giants. In the rivers and swamps, amphibians thrived. Descendants of the first fish to crawl onto land grew stronger, more diverse, more suited to a dual life in water and air. Some became hunters in the rivers, others ventured deeper into the forests, their lungs growing more reliable as they spent more time away from the water. It was in this time that another innovation changed everything: the amniotic egg. Some amphibians developed eggs with protective shells, no longer tied to laying them in water. These were the first reptiles. With this simple but powerful step, animals could now colonize drier lands, far beyond the swamps and rivers. It was a quiet revolution, and from it would descend the great dynasties of reptiles, dinosaurs, birds, and mammals. The Carboniferous was a time of richness, of abundance, of air heavy with life. The forests not only gave shelter, but also transformed the planet itself. When these massive plants died, their remains sank into the swamps, layering, compressing over millions of years into seams of coal, the black stone that would one day fuel human civilization. And yet, as in all of Earth's chapters, this abundance was not eternal. The forests, so lush and vast, would eventually face their own collapse. But for a time, the Carboniferous world was a paradise of green and shadow, of giant insects and rising reptiles, a vision of nature at its most exuberant. The Carboniferous forests, lush and towering, had given the world an atmosphere thick with oxygen and a stage filled with new opportunities. Yet the most important development of this age was not a giant insect or a towering tree. It was something smaller, quieter, but far more profound. The egg. Amphibians had already shown that vertebrates could live beyond the sea, but they remained tied to water. Their eggs, soft and fragile, needed to be laid in ponds and streams. Without moisture, they would wither and die. For all their progress, amphibians were still bound to the swamps. But then, evolution offered a new solution. Some creatures began to lay eggs with protective shells, eggs that could survive away from water, eggs with their own private environment inside. These were the first amniotic eggs, and with them came the true reptiles. The shell was not just a barrier. It was a self-contained world, carrying water, food, and protection for the growing embryo. With it, life had broken one of its last chains. Animals could now roam far from rivers, explore drier lands, and claim new territories. From these first reptiles came two great lineages. One led to creatures that would one day become mammals. The other gave rise to reptiles, and much later, birds. This quiet divergence would shape the history of all future vertebrates. As reptiles spread, the forests themselves continued their dominance. But abundance brings instability. The climate shifted, and the once humid swamps began to dry. Forests fragmented, rivers shrank, and with them, the great insects and many amphibians lost their homes. The rainforest collapsed, and in their place, drier landscapes emerged. It was a moment of both loss and liberation. Amphibians dwindled, unable to survive far from water, but reptiles, with their eggs and their hardy bodies, thrived in the new conditions. They were no longer tied to swamps. They could march across deserts, climb new hills, and fill the spaces left empty by others. The Carboniferous had been an age of green abundance, but now a new age dawned, one of resilience and adaptation. The reptiles, small and unassuming at first, were beginning a journey that would one day lead to empires of giants. The forests had given them the tools, the drying of the world had given them the need, and now the reptiles would give the earth something new, creatures fit to rule the land. The Carboniferous world, once humid and green, could not last forever. Around 305 million years ago, the climate began to shift. The vast swamps that had stretched across continents slowly dried, rivers shrank, rainfall lessened, and the great rainforest that had given life to so many species started to fragment. This event is known as the Carboniferous rainforest collapse. What had been one of the most fertile and oxygen-rich environments in Earth's history became scattered islands of forest surrounded by drier, harsher landscapes. The oxygen levels that once allowed dragonflies to grow to a metre across and millipedes to reach the length of cars began to fall. The giants of the insect world disappeared, unable to thrive in the new conditions. Amphibians, too, faced decline. For millions of years they had flourished in swamps and waterways, but as the wetlands retreated, so did their dominance. Their soft eggs and reliance on water kept them tied to environments that were vanishing. Many lineages faded into silence, but while some suffered, others adapted. Reptiles, with their amniotic eggs, were freed from the dependence on water. They could move into the drier lands where amphibians could not follow. Hardy and versatile reptiles spread across the continents, filling the niches left open by collapse. The drying of the rainforests reshaped the balance of life. It marked the end of an age of amphibian abundance and the beginning of a new era. The reptiles, once small and modest, now had the stage. In time, they would grow into forms far larger and stranger than the Earth had ever seen. And still, the planet itself was changing. The continents, once scattered, began to draw together. Slowly, they fused into a single vast landmass, Pangaea, a supercontinent that would dominate the Earth for millions of years. The collapse of the rainforest was a tragedy for many species, but it was also a turning point. Out of loss came possibility. Out of shrinking forests came open lands, and in those lands, the reptiles, quiet inheritors of the Carboniferous, prepared to rise. As the Carboniferous faded and the Permian period began, about 299 million years ago, Earth looked very different. The continents had drawn together into a single immense landmass, Pangaea. It stretched from pole to pole, vast and dry in its interior, fringed by long coasts and deserts. Where once swamps and rainforests had dominated, now broad arid plains and shifting climates set the stage. The creatures of this world were new as well. Reptiles, freed by their amniotic eggs, spread across the land in countless forms. Some were small and nimble, scurrying through dry undergrowth. Others grew large, their bodies heavy, their limbs strong, and among them were creatures that looked neither quite like reptiles nor quite like the mammals that would come later. These were the synapsids, sometimes called mammal-like reptiles, though they were their own branch of life's tree. One of their champions was Dimetrodon, a predator with a sail-like spine rising from its back. Though it lived long before true dinosaurs, its form is one of the most iconic of this age. Other synapsids were herbivores, with sturdy bodies and heavy jaws designed to chew tough plants. They were the ancestors of mammals, shaping a lineage that would not flourish until much later, but already experimenting with traits we might recognize: stronger teeth, more complex jaws, perhaps even warm-bloodedness in its earliest beginnings. Meanwhile, true reptiles diversified into many directions. Some gave rise to early forms that would one day lead to the great reptiles of the Mesozoic. Others remained small, survivors that clung to quieter niches. The Permian world was rich in ecosystems, despite its harsh conditions. Forests of conifers grew across certain regions. Insects continued to buzz, though no longer as gigantic as their carboniferous ancestors. Seas held trilobites, mollusks, and fish, though many groups were past their prime. On land, life pressed forward, adapting to the new climates of Pangaea. It was a time of invention, of exploration, of diversity. Life had spread into every corner it could, and yet, beneath this abundance, pressures were building. The Earth's crust shifted, volcanoes stirred, climates swung. The Permian period would rise to a peak of life, and then, in its final act, fall into a silence deeper than any extinction before it. For now, though, the Permian world was alive, a land of sails and teeth, of deserts and forests, of ancestors whose stories would echo for millions of years. The Permian world had been rich with diversity, synapsids roaming the land, forests stretching across Pangaea, seas alive with mollusks, fish, and corals. But around 251 million years ago, the Earth faced a catastrophe unlike anything before or since. It would come to be known as the Great Dying, the most severe extinction event in our planet's history. The story begins deep within the Earth. In what is now Siberia, a massive volcanic region erupted with fury. Not just a single eruption, but wave after wave over hundreds of thousands of years. Lava spilled across the land in sheets, covering millions of square kilometers. The air filled with ash and toxic gases. Carbon dioxide and methane surged into the atmosphere in volumes so vast that they altered the very balance of the planet. At first came heat. Temperatures rose as greenhouse gases trapped the sun's warmth. Oceans grew warmer, oxygen dissolved less easily, and life in the seas began to struggle. Coral reefs collapsed. Trilobites, survivors of earlier crises, vanished forever. Entire groups of marine creatures, from brachiopods to ammonoids, dwindled into silence. Then came the cascade of consequences. With oxygen scarce, parts of the oceans became stagnant and suffocating. Hydrogen sulfide gas, poisonous to nearly all life, seeped upward from the deep. Forests on land withered, choked by acid rain and shifting climates. Synapsids, the dominant animals of the Permian, fell one by one. Even mighty predators like Dimetrodon were gone by the end. By the time the crisis had ended, about 95% of all marine species and 70% of land species were extinct. The Earth itself seemed wounded, its ecosystem shattered. Where once there had been abundance, now there were empty landscapes, silent seas, and broken chains of life. And yet, not everything perished. Small, unassuming creatures endured. Some reptiles, some amphibians, and a few fragile survivors among the synapsids. These remnants, clinging to existence, would inherit a quieter world. The Permian-Triassic extinction was more than a disaster. It was a reset. Life, which had taken hundreds of millions of years to build its complexity, was forced to begin again from scattered fragments. The memory of this event is written in the rocks, in layers of ash and barren fossil beds, telling us that even the strongest ages can pass in silence. But from this silence, life would rise again, slowly at first, cautiously, and then with new strength. In the Triassic, a new caste of creatures would step into the light. Among them were the ancestors of a group that would dominate the Earth for the next 160 million years, the dinosaurs. After the Great Dying, Earth was quiet in a way it had never been before. The Permian had ended with life nearly erased, and the Triassic began in a world stripped bare. Forests were thin, seas were empty, and food chains were fragile. What had once been vibrant ecosystems were now only scattered survivors, clinging to existence. Yet even in such silence, life has a way of beginning again. Over the next millions of years, those survivors spread into the empty spaces left behind. Small reptiles became more numerous, filling the roles once held by synapsids. Amphibians, though diminished, continued in the rivers and wetlands. Insects returned to the skies, pollinating the first of the hardier plants that could withstand harsher climates. The climate of the Triassic was hot and dry. Much of Pangaea's vast interior was desert, with temperatures soaring under the relentless sun. Rain was rare, rivers often seasonal, and survival demanded resilience. Many creatures grew tough, built to endure long droughts or sudden floods. Synapsids, though broken, were not gone. Some persisted in smaller, humbler forms. Among them were ancestors of the mammals, small, quick, nocturnal, living in the shadows of the new reptilian rulers. They were no longer dominant, but they endured, quietly keeping their lineage alive. Meanwhile, reptiles began to experiment. Some returned to the oceans, evolving into streamlined swimmers that would reclaim the seas. Others stayed on land, ranging from small lizard-like forms to larger, heavier-bodied creatures that walked with more upright legs. The way animals moved was changing. Creatures with limbs beneath their bodies could run faster, hold their weight more efficiently, and chase prey across open ground. Among these Triassic reptiles was a group that would one day rise above all others, the archosaurs. From them would come crocodiles, pterosaurs, and dinosaurs. At first, they were small and unremarkable, but in the emptiness left by extinction they had room to grow. The Triassic was a time of recovery, but also of invention. From the scattered remnants of life, new forms were being tested. The Earth had reset, and evolution was quietly shaping the creatures that would one day dominate land, sea, and sky. For now, it was still a world of survivors, a fragile balance beneath the hot sun of Pangaea. But in the shadows, history was preparing its next great dynasty. For tens of millions of years after the Great Dying, the Triassic world slowly healed. Reptiles grew larger and more varied. Synapsids held on in smaller forms, while early archosaurs, ancestors of crocodiles, pterosaurs, and dinosaurs, began to rise. Forests returned in scattered patches, insects flourished again, and the seas slowly filled with fish, corals, and mollusks. It might have seemed as though Earth had escaped its darkest hour and entered a time of steady rebuilding. But the story of life is never still. Around 2.1 million years ago, another crisis swept across the planet, the Triassic-Jurassic extinction. Though not as catastrophic as the Great Dying, it was enough to change the course of evolution forever. The cause was once again the restlessness of the Earth. As Pangaea began to rift apart, cracks opened in the crust. Massive volcanic eruptions shook the planet, releasing vast amounts of carbon dioxide and methane. The air grew heavy with greenhouse gases, the climate warmed, and the chemistry of the ocean shifted. Acid rain scorched the land. Seas turned anoxic in places starved of oxygen. For many creatures, the change was too much. Large amphibians, which had once ruled rivers and swamps, disappeared. Several groups of reptiles, including many archosaurs that had competed with the early dinosaurs, were swept away. Plants struggled as climates shifted rapidly between wet and dry. In the oceans, too, the losses were heavy. Many marine reptiles, mollusks, and invertebrates perished. Coral reefs collapsed once more, and ecosystems built over millions of years dissolved in a geological moment. Yet out of this loss came opportunity. Dinosaurs, once small and relatively minor, survived the extinction. With their competitors gone, they expanded into the empty niches. Some grew massive, towering above the trees. Others took to the seas and skies, their bodies adapted to new environments. The stage was cleared, and the age of dinosaurs began in earnest. It is a pattern that repeats throughout Earth's story: collapse, survival, renewal. Extinction is not only an ending, but also a doorway. Each time the planet has fallen silent, those who endure inherit a changed world. The Triassic extinction cleared the way for one of the most iconic dynasties in history, a dynasty that would rule for over 160 million years. From this point onward, Earth would be known as the world of the dinosaurs. The Triassic had ended in fire and silence, but from its ashes rose one of the most remarkable chapters in the history of life, the Jurassic period. Around 200 million years ago, the Earth was warmer, wetter, and greener. Pangaea, the great supercontinent, was breaking apart. As it did, new coastlines formed, climates softened, and life once again flourished in dazzling abundance. Forests of conifers, cycads, and tree ferns spread across the continents. Rivers wound through valleys filled with lush vegetation. In this rejuvenated world, the dinosaurs, freed from competition, began their long and majestic reign. Some grew immense, like the towering Brachiosaurus and Diplodocus, whose necks reached high into the canopy to graze on leaves that no other creature could reach. Their size was not only a defense, it was a strategy, allowing them to feed safely above the chaos of the forest floor. Others became swift hunters. The Allosaurus, with its long tail and powerful jaws, stalked the plains in search of prey. Smaller carnivores darted among the ferns, agile and cunning, hunting in groups or ambushing from cover. Each form, from the giant to the fleet-footed, seemed designed to fill a role in the unfolding drama of life. But the Jurassic was not only the age of dinosaurs. In the skies, evolution took another leap. The first true flyers appeared, the pterosaurs. With wings of skin stretched over elongated fingers, they soared above rivers and seas, feeding on fish and small animals. Some were no larger than a sparrow, others spanned several meters. They were the first vertebrates to conquer the air, long before birds. The oceans too came alive with predators. Marine reptiles like ichthyosaurs swam like dolphins, sleek and fast. Plesiosaurs and plesiosaurs ruled the deeper waters with long necks or powerful jaws. Coral reefs thrived once again, hosting colourful ecosystems of fish and invertebrates. And in the shadows, unnoticed amid this grandeur, small creatures scurried, warm-blooded, furred and alert. They were the first true mammals, descended from the snapsids that had survived the Great Dying. These tiny nocturnal animals fed on insects and seeds, keeping to the night while giants ruled the day. The Jurassic world was a symphony of movement and colour, a planet in full bloom. Life had not only recovered, it had reached a new peak. Dinosaurs ruled the land, pterosaurs the skies, reptiles the seas, and mammals the dark corners between. But even in this time of balance, the Earth was never still. Deep within, tectonic forces continued to reshape the continents. The oceans widened, volcanoes flared, and climates shifted slowly. The stage was already being prepared for another transformation, one that would bring flowers, colour, and eventually the end of the giants. As the Jurassic world gave way to the Cretaceous, around 145 million years ago, the Earth entered an age of colour and expansion. The continents, once united as Pangaea, had drifted apart into separate lands, surrounded by widening oceans. New coastlines and islands formed, and with them came new climates, new habitats, and new opportunities for life to evolve. Forests changed. Ferns and conifers still towered across the land, but something new appeared among them: flowers. The first flowering plants, or angiosperms, emerged quietly and spread rapidly. They were smaller at first, modest shrubs with delicate blooms, but their invention, the flower itself, transformed life on Earth. With colour and scent, flowers attracted insects, forging a partnership that would reshape the planet. Pollination became more efficient, reproduction more widespread. Bees, butterflies, and beetles diversified, drawn to the promise of nectar. the world grew more vivid, filled with colour, fragrance and motion. Dinosaurs continued to rule, adapting to the changing landscapes. Herbivorous giants like Argentinosaurus and Iguanodon roamed the plains, their herds shaking the ground as they moved. Spiked and armoured creatures like Ankylosaurus and Triceratops evolved powerful defences against predators. In the forests, smaller dinosaurs became nimble and alert, darting between trees and feeding on fruit or insects. Predators, too, reached new heights. The Tyrannosaurus rex, perhaps the most famous of them all, emerged near the end of the Cretaceous. With massive jaws, keen senses and formidable strength, it stood as the apex hunter of its age. Yet even T-Rex was only one of many. Raptors, agile and intelligent, hunted in packs. Others took to the skies, evolving feathers not just for warmth but for flight. Yes, feathers. What began as a simple adaptation for insulation in small dinosaurs became something far greater. In creatures like Archaeopteryx, feathers transformed into wings, and flight took its second great leap. This time, not with leathery membranes like pterosaurs, but with light, feathered elegance. The first true birds appeared, carrying forward a lineage that would one day fill the skies. The oceans too were alive with giants. Mosasaurs, sleek and serpentine, hunted across the warm seas. Plesiosaurs glided gracefully beneath the surface, and ammonites, spiral-shelled relatives of squids, floated in vast numbers, their shapes now immortalized in stone. Coral reefs spread widely once again, sheltering new forms of fish and crustaceans. The Cretaceous was a time of abundance, a golden age of ecosystems rich and interwoven. Life had achieved a balance of breathtaking complexity. Plants and animals co-evolved, shaping one another, driving forward an explosion of forms and behaviours. And yet, as in all of Earth's long history, even this brilliance would fade. Deep in the blackness of space, a silent traveller was already on its way, a visitor that would end one dynasty and begin another. For millions of years, the Cretaceous world thrived. Forests bloomed, rivers teemed with life, and the great reptiles ruled land, sea and sky. It was a world both ancient and vibrant, so complete, so full, that it might have seemed eternal. But nothing on Earth is ever truly permanent. About 66 million years ago, a small visitor arrived from the dark reaches of space, a rock only 10 kilometers wide. It approached silently, unseen, until the moment of impact. When it struck the shallow seas near what is now the Yucatan Peninsula, it unleashed a force greater than any volcano, greater than all the weapons humanity would one day create. The energy released was unimaginable. The asteroid hit with the power of billions of nuclear bombs, vaporizing everything within hundreds of kilometers in an instant. The shockwave raced across continents, flattening forests, boiling oceans, and setting the very air alight. Mountains of debris and molten rock were hurled skyward, some leaving the planet entirely. Within hours, tsunamis circled the globe. Within days, the sky was darkened by dust and soot. The sun vanished behind a shroud of ash. The light of day became as dim as twilight, and the warmth of the planet began to fade. For weeks, then months, and perhaps years, sunlight could not fully reach the ground. Photosynthesis stopped, plants withered, herbivores starved, and the carnivores that fed on them followed soon after. Across land and sea, ecosystems collapsed. The age of the dinosaurs, the proud rulers of the Mesozoic world, came to an end. More than 3/4 of all species vanished. In the oceans, ammonites disappeared. The great marine reptiles perished. On land, the towering herbivores and their predators fell silent. Only the smallest creatures, those that could burrow, hide, or endure scarcity, survived. And yet, even in such devastation, the story of life did not end. Some lineages endured. Tiny mammals, once overshadowed by giants, found refuge underground. Birds, descendants of small feathered dinosaurs, survived the cold and hunger. When the dust finally settled and sunlight returned, it was these survivors who stepped into a transformed world. The age of reptiles was over. The age of mammals was about to begin. The end of the Cretaceous was not just an extinction. It was a turning of the page, a reminder written in ash and stone that even in destruction, the seeds of renewal are sown. The earth, wounded and changed, would heal again. And from that healing would rise a new kind of life, smaller, warmer, and one day capable of wondering how it all began. When the light of the sun finally returned to Earth, the world it revealed was quiet and empty. The great forests were gone, the skies were still, and the thundering footsteps of the dinosaurs had faded into memory. For the first time in over 160 million years, the Earth was without its towering rulers. Yet in the shadows, the survivors stirred. Tiny mammals, creatures that had spent the age of dinosaurs hidden in burrows, forests, and darkness, began to emerge. They were small, warm-blooded, and quick, with sharp senses and clever instincts. For millions of years they had lived cautiously under the feet of giants. Now the world was theirs to explore. At first they were modest in form, shrew-like insectivores, scavengers, and seed-eaters. They lived among the ashes of fallen forests, feeding on insects and plants that had begun to return. The air was still cool, the climate unstable, but slowly green life reappeared. Ferns reclaimed the land, then trees, then flowering plants once more. As vegetation spread, so did insects, and with them came the small mammals that hunted or gathered among them. The planet, once scarred by the asteroid's fury, began to heal. Rain returned. Rivers flowed again. Over time the skies cleared, and warmth returned to the soil, and in this renewed world the mammals began their quiet rise. Some grew larger, adapting to the open plains and new forests. Others returned to the trees, their fingers and tails growing more agile. Still others took to the water, their bodies reshaping to swim and dive. What had been a small, overlooked group now diversified into countless forms, each exploring a new way to live. Among them were the ancestors of elephants and whales, of lions and deer, of apes and humans. In only a few tens of millions of years, a blink in geological time, the mammals had spread to every corner of the planet. But this dawn was not only about size or strength, it was also about intelligence. Mammals relied on care, on nurturing their young, on memory and learning. Their survival was not built solely on teeth or armour, but on adaptation and awareness. And in that capacity to learn, to feel, and to remember, the roots of consciousness were deepening. The world after the dinosaurs was quieter, but more intricate. It was a place of morning light, of green renewal, of small creatures learning to thrive in the silence left behind. And though the earth had been reshaped by catastrophe, life, as it always had, found a way forward. From ashes and shadow, warmth returned. From loss, curiosity awoke. And from the smallest of survivors, a new chapter of wonder began. The mammals that inherited the earth after the great extinction began as modest survivors. But time, patient, vast, and ceaseless, transformed them. Over tens of millions of years they adapted to nearly every corner of the planet, from the frozen poles to the burning deserts, from deep oceans to the heights of mountains. Evolution, once again, began its slow artistry. In the open plains of ancient grasslands, some mammals grew long legs and powerful lungs, built for running across wide distances. These were the ancestors of horses and antelopes. In the forests, others developed hands and grasping tails to move through branches, giving rise to the primates. In the oceans, a few returned to the element their distant ancestors had once left behind. They became whales and dolphins, exchanging limbs for fins and nostrils for blowholes, singing in the dark waters that had once belonged to reptiles. This quiet unfolding was not without struggle. The earth itself remained in motion, continents drifting, mountains rising, climates shifting. Warm ages came and went, followed by long chills. Species appeared, flourished, and disappeared again. But through each wave of change, the thread of life endured, flexible, inventive, unbroken. By the Eocene epoch, around 50 million years ago, the planet was warm and rich with life. Tropical forests stretched nearly to the poles. Mammals had reached their golden age. Some stood taller than houses, while others remained no bigger than a mouse. Birds filled the skies, insects hummed through jungles, and coral reefs glowed beneath the sea. Then, slowly, the earth began to cool. Ice crept into the polar regions. The lush forests retreated, replaced by grasslands and open steppes. Animals evolved to meet the new challenges. Thicker coats, stronger muscles, sharper senses. Predators and prey entered a new dance, one of speed and endurance rather than size and might. Amid this changing world, the primates began to stand out. They were not the largest or the strongest, but they had hands that could grasp, eyes that could judge depth, and minds that could remember and plan. In the forests of Africa, their ancestors watched the world change and adapted with thought, not just instinct. The long arc of evolution is not a ladder but a branching river. Countless lines diverged, some vanishing, others continuing toward unforeseen futures. Life was not aiming for a goal, it was exploring possibilities. And among those possibilities, intelligence slowly deepened. The mammals had inherited a living world shaped by fire, ice, and chance. Through each trial they changed and endured, carrying forward the story that began long before them, in the ocean's dark beginnings, in the cells that first breathed. The Earth, as always, was not simply alive, it was becoming. The long arc of evolution carried life into a new rhythm, one shaped by cycles of warmth and cold, advance and retreat. Around 2.6 million years ago, the Earth entered a new chapter known as the Quaternary period. It was an age of ice and rhythm, when glaciers moved like slow tides across the continents, carving valleys, shifting rivers, and testing every living thing that called the planet home. The ice ages did not arrive all at once. They came and went in vast cycles, each lasting tens of thousands of years. During the coldest times, colossal ice sheets stretched from the poles, burying much of North America, Europe, and Asia under kilometers of frozen weight. Mountains wore smooth caps of snow that never melted. Seas retreated as water locked itself in ice, revealing land bridges that connected continents, pathways across which animals and early humans would one day wander. Between these freezes came warmer interludes. When the glaciers withdrew, forests returned, and rivers ran freely again. Life adapted to this pulse, flowing like breath, expanding and contracting with the climate's rhythm. For many animals, survival meant movement. Mammoths, with their long hair and curved tusks, roamed the cold grasslands. Saber-toothed cats hunted in the shadows of glaciers. Herds of bison and reindeer followed the seasons, migrating across endless plains of frost and stone. Each species, in its own way, became a thread in a delicate balance between cold and renewal. The changing climate also shaped the evolution of a new kind of mammal. Us, early humans, our ancestors, emerged in Africa, where the climate too was shifting. Periods of drought and rain transformed the landscape, turning forests into savannas. To survive, our ancestors stood taller, moved farther, and thought more deeply. They learned to use tools, to hunt, to make fire, and slowly, over hundreds of thousands of years, they spread outward, across deserts, through forests and into the icy frontiers of the north. Each glacier's retreat opened new lands. Each return of ice demanded new endurance. The ice ages sculpted not only the Earth's mountains and valleys, but also the resilience of the beings who walked upon them. And though the glaciers would come and go, their legacy would remain. The rivers they carved, the soils they left behind, and the species they shaped would form the world we know today. It was during these ages of challenge that life learned both patience and persistence. Every thaw was a chance for renewal, every freeze a test of endurance, and amid it all, humanity's story was quietly beginning. One small branch of the great tree of life, standing at the edge of the cold, staring into the dawn. From the frozen silence of the ice ages to the green and crowded world that followed, Earth's story reveals a truth that can feel both humbling and serene. Extinction is not only an end, it is part of the rhythm of life itself. 5 times before our own age, the planet has been reset by catastrophe. Each mass extinction ended an era and began another. The Ordovician seas froze, the Devonian oceans suffocated, the Permian world burned, the Triassic cracked open and boiled, and the Cretaceous fell beneath the shadow of an asteroid. Each time the Earth grew quiet, and each time from that quiet life returned. Different, reshaped, renewed. To study these ages is to see that extinction is not failure. It is transition. Nature does not mourn the past as we do. It transforms it. The remains of ancient forest became coal, the bones of marine creatures became mountains, and even the deaths of entire species cleared space for others to evolve. Life is not a line, but a circle, a pulse that never truly stops. Every extinction erases, but it also opens the way for new forms to appear, new ideas to be tested, new balances to be found. If we could step outside time and look at Earth's history as one continuous breath, we might see how closely creation and loss are intertwined. The fall of one world gives rise to the next. The end of the dinosaurs allowed mammals to inherit the land. The collapse of ancient forests prepared the soil for new growth. The cooling of oceans invited coral and shell to begin again. Even now, as we live within what some scientists call the 6th extinction, the pattern continues. Humanity, through its reach and its power, has altered the climate, moved species across continents, and changed the chemistry of air and sea. Yet the Earth itself remains alive, still breathing, still adapting. This is not to say that loss should be taken lightly. Every extinction carries sorrow. But in the deep story of our planet, even endings are part of continuity. Every silence is temporary. The same cycle that erased trilobites and ammonites once gave rise to us, to creatures capable of memory, empathy, and reflection. In that sense, every vanished world still lives within us, carried in the cells of our bodies, in the minerals of our bones, in the air we breathe. The past never truly disappears. It changes form and flows onward, quietly, endlessly, like the oceans that first cradle life itself. When we look back across billions of years, it is easy to see the resilience of life, its power to return, to adapt, to begin again. But beneath that resilience lies another truth. Life is fragile. It endures only through balance, a balance so delicate that a shift in the air, the ocean, or the light of the sun can change everything. Throughout Earth's history, small changes have had vast consequences. A slight cooling of the atmosphere can blanket the planet in ice. A burst of volcanic gases can turn the seas acidic. A single rock from space, crossing the void at unimaginable speed, can erase whole lineages in a heartbeat. Life has always existed at the edge of chance, strong enough to survive, yet never invincible. Even now that balance continues. The forests that breathe out oxygen, the oceans that cradle warmth, the winds that carry moisture, all of them depend on one another in quiet, intricate harmony. Every living thing, from the smallest bacterium to the largest whale, is part of this exchange. The breath of one becomes the breath of another. We humans are a recent part of this story, arriving only moments ago in geological time, and yet, in that brief instant, we have learned to alter the very systems that sustain us. We change the air, warm the seas, shape the land, and move species beyond their ancient boundaries. Our touch has grown vast, too vast perhaps for such a fragile world. But fragility is not weakness. It is the price of beauty. The same balance that makes life vulnerable also allows it to be varied and creative. The thin layer of atmosphere that shields us from space also carries the clouds, the rain, and the breath of every living thing, the same sunlight that can scorch also gives energy to grow. Perhaps that is why the Earth's story feels so human. It mirrors our own, our capacity to build, to destroy, to endure, to change. The planet has known devastation, but it has also known renewal. Its memory is long, but its patience is finite. To understand the fragility of life is not to despair. It is to see clearly that everything we love, every forest, every creature, every ocean, exists because of a balance that has been maintained for nearly 4 billion years, and knowing that, we are given both a warning and a gift: to live gently, to remember the thinness of the line that sustains us, and to keep the rhythm of the Earth unbroken for as long as we can. The story of life on Earth is long beyond comprehension. 4.5 billion years of creation, destruction, silence, and song. And yet, even now, it remains unfinished. Each sunrise, each breath of wind, each ripple on the sea carries forward a story that is still being written. From the first sparks of chemistry in a dark ocean, to the forests that now sway beneath the sky, to the human voice that speaks these words, all are threads in the same vast tapestry. Every extinction, every birth, every forgotten creature is part of it. The Earth remembers, even when we do not. When we study the layers of rock beneath our feet, we are reading an ancient memory. Within those stones lie echoes of frozen seas, vanished forests, and the bones of beings who once looked upon a different sky. They tell us that the world has ended many times and yet never completely. Life endures. It always finds a way to return, and now we stand within that same story, aware of it, capable of shaping it. We are not separate from the history of the planet. We are its newest chapter. The warmth of our fires, the light of our cities, the choices we make, all of them ripple outward into this ancient rhythm of creation and loss. Perhaps someday, long after we're gone, the Earth will again reshape itself. Mountains will fall, new seas will rise, and new forms of life will emerge from the remnants of what we leave behind. To them, our time will be a layer of memory, a thin band of colour in the rock, and yet for now, in this brief moment of sunlight, we are here, living at the edge of deep time, part of a universe still unfolding. If there is a lesson in the story of the 5 great extinctions, it may be this: that every ending carries within it the possibility of renewal. The Earth does not promise permanence, only continuity. So, as the night falls and the stars appear, the same stars that watched over the birth of this planet, we might ask a quiet question, one that has no final answer. What will we leave behind in the great story of life? Perhaps only this, that for a moment in the long history of the world we looked up, wondered, and knew that we were part of something vast and alive.